Hey everyone, my name is Zan, and I'm the lead of the Orbital Subteam. So unlike some of the other teams, we're actually pretty small. It's just me and Liam and Aiden. Aiden will be available later to talk in the networking session. Um, so I think I got a little bit feedback there. Anyway, so here are control, attitude determination, and we also perform orbital case studies. So first things first, not everyone will probably know what this is, but what actually is attitude? So try to show it here with this satellite spinning here, but attitude is the orientation of the satellite with respect to something else like the Earth. It also describes the satellite's rotation about its axes, just like the satellite to the right. So this is a good example of attitude here. This is a Kentucky satellite, which is stabilizing with respect to the magnetic field lines. But why most satellites control their attitude? So they do this for multiple reasons, like better communication, but also improved operation to a satellite's payload, like you heard before. Like I mentioned before, this is a satellite which attitude is stable in. So what does NEUDOSE do for attitude? We use passive magnetic attitude control, which aligns one of the satellite's axes to Earth's local magnetic field lines. And that's what I'm trying to show here on the right, is one of the axes is actually stabilizing and aligning with one of these magnetic field lines. So that's what the passive magnetic attitude control system does. It's made out of bar magnets and hysteresis rods. And we actually use the y-axis of the satellite to stabilize with the magnetic field lines. So what we do is we run simulations to actually see how well the system performs in orbit. And that's what you see over here on the right. So this represents the angular velocities about each satellite axis. And this represents the pointing error with respect to the local magnetic field lines. So it's basically just the error angle between the y-axis of the satellite and the magnetic field line. The other thing we're doing is attitude determination, which is basically estimating what the satellite's attitude is. So this is a render of the satellite in orbit using SDK, which is our orbital modeling software. And in order to do attitude determination, we need to have some physical vectors. So on board the satellite, we can measure Earth's magnetic field vector, and we can also construct a sun vector from the solar panel currents. And then what we will do is we'll downlink those vectors, as you heard in the comms presentation, and then we can actually estimate the attitude on the ground. We also do a variety of case studies, like I mentioned before. So one of the main ones we've done recently is estimating the power generation of the solar panels. So this shows over the whole year of the mission what the power generation is. It's called the orbit average power. Another thing we've done is rendering the satellite for use in SDK. So this is a 3D render in our orbital software, and this better model made our models a lot more accurate, because before we were just using kind of a standard satellite model, but now we have one that actually represents our satellite. And another example of one of our case studies would be basically simulating passes of the communication software to see basically how our communication system performs. So thank you all for listening, and Aiden will be around in the booth to answer any questions you have.